Today we will be talking about permutations and combinations in Eecs 203. To start off, permutations and combinations are two different ways of picking objects out of a set, where permutation, the order of the things picked matters, and combinations where the order of the things picked does not matter. An example of a permutation are combination locks, where you pick numbers in a certain order, where a combination is picking three different colors in the rainbow, since if I pick red, orange, and yellow, it is the same as picking yellow, orange, and red, and the order does not matter in the way I pick them. Now let's take a deep dive into permutations. And the definition of a permutation are the number of ways to choose k things out of a set of n things in order. In order are the key words in that definition. Now, how many ways are there to pick the first thing in a set of n? Now, since there are n things, there must be n ways to pick, since we can pick either of the n or one of the n things in the set. Now that we have that, how do we pick the second object out of the set? Now, since we already picked one, there's n minus 1 remaining, so there are n minus 1 ways to pick this. Now assume that we have already picked k minus 1 things. How do we pick the last or kth thing? Now, intuition tells us that there must be n minus k objects left, but if you look up at the second, it's n minus 1, not n minus 2, since, well, we start off at n, not n minus 1. So that means that when we pick the k thing, there are still n minus k plus 1 things remaining. Now, by the rule of multiplication, how many ways can we pick k things with all of these already found out? So now we multiply all of these together. We have n times n minus 1 all the way down to n minus k plus 1, which actually simplifies as n factorial over n minus k factorial. Now let's take a deep dive on combinations. And a combination are the number of ways you can pick k things out of n things regardless of order. So let's take a look at a permutation going back to the previous slide of n and k. How many different ways are there to pick k things out of n? Well, we just went over this. It's n factorial over n minus k factorial. Now, what is the main difference between a combination and a permutation? Well, that means that combinations don't depend on order, meaning that there will be more permutations than combinations since they rely on order. But by how many? Well, this is done by the amount of objects being selected. If there is an order, there are k factorial different ways you can arrange this. So that means that if we take out the division, if we divide out the k factorial part of a permutation, then we get the combination of that value. So the formula for combinations ends up being n factorial over n minus k factorial, which is permutations, divided by k factorial, which determines the order. Now let's take a look at an advanced permutation and combination question, a poker 3 of a kind. Assume that we have a standard deck of 52 cards with 13 ranks and 4 suits, and a 3 of a kind is a set of 5 cards containing 3 of the same rank. How many ways can we create a hand of 3 of a kind is what we want to try to find out. So how many ways are there to pick the rank of a 3 of a kind? So that means that there are 13 different ranks, so that means there are 13 different ways to pick the rank. Now that we picked the rank that we wanted for our 3 of a kind, we must select the 3 cards of the rank with different suits that we want. Now there's 4 cards with this rank, but we only want 3 of them. So we choose 3 of them, and it does not depend on the order we choose them, so we will do a combination, 4 choose 3, which equals 4 since the order does not matter. Now that we pick those 3 cards, what about the other 2 in the hand? We must pick them too, and we don't want them to be the same rank as the 3 of a kind, otherwise it'll create a 4 of a kind. So we're left with 52 minus 4, which is 48 different ways to pick this next card. Now, we don't want to pick a card that is in the same rank as the 3 of a kind and this 4th card, so we will pick with 44, which is 48 minus 4, since we don't want to create a 4 of a kind or a full house. Additionally, we must divide this by 2 factorial because we can pick the 4th card before the 5th card just as easily as we can pick the 5th card before the 4th card. Therefore, when we multiply everything, we get that there are 54,912 different ways of making a 3 of a kind, Thank you for listening, and I will provide more lessons if needed.